Hello friends, now we are going to say about Pauli's exclusion principle. This also explains us how electrons occupying these orbitals in an atom. Earlier we have studied about two more rules, those are Abbo principle and Hund's rule. In Abbo principle we understood that how electrons occupying these orbits as well as subshells in a systematic manner. And in the second Hund's rule, we understood that how orbitals or degenerate orbitals in a subshell are being occupied, first all singly and then pairing taking place. Now in this Pauli's exclusion principle we are going to study that. From this we can understand that how electrons are occupied in a particular orbital, how many electrons can be accommodated in an orbital. This you can understand from Pauli's exclusion principle. It states that no two electrons in an atom have same set of quantum numbers. Means if we compare the quantum numbers of any two electrons in an atom, they will be having completely at least one different quantum number. They might have three quantum numbers same, at least one will be differed. This is possible when there exists only two electrons in an orbital with opposite spins. So this concludes that an orbital can maximum accommodate only two electrons, those two also with opposite spins. So whatever the orbital it is, its accommodation capacity is 2 for electrons. This is explained by Pauli's exclusion principle. Let us see once explanation with one example. Let us consider helium. If you see its configuration 1s2 as its atomic number is 2. If you see diagrammatically, there are two electrons in its 1s subshell. If we write the quantum numbers for these two electrons, let us try to compare them. First let us write for this electron. Let us call this first electron. N value for this electron will be, as it is in the first subshell, 1. L value will be 0, as we know. For the electrons present in the S subshell, L value will be, or azimuthal quantum number value will be 0, and M value, magnetic quantum number, is also 0 for this electron, because L value itself it is 0. M values will be minus L2 plus L including 0, so M value will come as 0. And S value, that represents spin quantum number for this electron. As it is the clock upward direction, it represents the clockwise spin, so it will be represented as plus half. Let us write now the quantum numbers for this second electron. For this also N value will be 1 and L value also 0 for this two. M value is also 0 because the L value are already 0. And the S value, here this electron is in the anti-clockwise spin. This represents its S value as minus half. So even though these two electrons are in the same orbital, they have three quantum numbers the same, but one quantum number is differed, that is spin quantum number. In this way, any two electrons, if we compare in an atom, they might be having one or two or three quantum numbers same, but one will be different compulsory. That is given as statementally as no two electrons in an atom have same set of quantum numbers. This limits the number of electrons in an orbital to 2. Those two also, one with the clockwise spin, the other with the anti-clockwise spin. This is Pauli's exclusion principle.